In this two-part series on C# exception handling, we're first going to look in detail at how exceptions work in C#. And then in the second video, we'll look at the individual Selenium exceptions you're likely to encounter. In this video, we're covering 5 topics. The first, the keywords, try, catch, finally and throw. Secondly, the types of exception you're likely to run into. Third, passing exceptions up the stack. And fourth, scope of variables in that try, catch block. And then finally, we'll look at how to throw your own custom exceptions. Why do we get exceptions? Okay, in this example block of code, we get an exception because the common language runtime has found an exception to the rules you've laid out in your code. So in this case, there is no file text.txt, and when we run this application, we hit an unhandled exception, and the common language runtime, the CLR, raises an exception object that contains all of the information that's known about the problem. And when you're running in debug mode and you hit that exception, you can view that exception object by adding an entry to the watch list, and you can use the naming convention $exception, and that will show you the exception object that has been created as the CLR hit the unhandled exception. And that exception object contains a couple of pieces of information that are useful. Firstly, the type of exception. So if you look in this field, it's a system IO file not found exception. Secondly, you'll get the message that's associated with this exception. So could not find file XYZ. Thirdly, you'll get the source of the exception, which in this case is system private core lib. We'll talk more about this in a minute. And lastly, the other fourth piece of information that you'll be interested in is the inner or the base exception. So this particular exception has been inherited from the system.exception class. We'll talk more about that in a minute as well. Now, this information in essence gives us everything we need in order to handle this exception next time it happens and prevent our application grinding to a halt as we run into an exception because the rules we've laid out in our code have not considered the condition that the exception has been raised for. The problem we need to resolve is stopping everything coming to a grinding halt when we run this program. We need a way to catch the exceptions as the program runs, which is where this try, catch, finally block of code comes in. We wrap the code that we are executing in the try block, and that try block will then catch any exceptions as it executes, and any caught exceptions will be handled by the catch block, which is designed to hold the code that you execute when a particular type of exception is raised. So essentially anything that is raised as an exception in the try block tells the CLR to pass that exception to the catch block where it will be handled, and then once handled within the catch block we'll run the code that's contained within the finally block. Note that this finally block is executed even if there isn't an exception caught in the try block, and it is also executed even if there is an exception and the code in the catch block is executed too. You'll notice in this that the catch block of code has a parameter passed to it of type exception, and what happens is the type of exception that is raised in here is matched to the type of exception that is specified as the parameter to the catch block of code. In this case, when you specify the parameter as exception, it will catch any type of exception. More on different exception types in a moment. But that exception object is then held within the EX variable that we've specified here in the parameters, and we can then access that exception object with the EX variable name that we've provided here, and we can access the properties in there like the message property that we spoke about just now. If we place a breakpoint here in our code, and if we run this piece of code, we'll notice that the execution stops at our breakpoint because in our try block an exception was raised, it was passed to the catch block. That exception is now contained in the variable EX, and we can add that to the watch list, earlier to the watch list, and it contains the same sort of information. Our variable contains an object of type exception. The exception type is a system IO file not found exception type. We've got the file name held in this object. We've got the inner exception, which is the base exception class system.exception. We've got the message, and we've got the source of that exception too. So if we continue the execution, you'll notice that the console write line command is executed, and then we move on to the finally block of code where we execute the code in the finally block. And if you look at this in the console application, you'll see here that we've executed that finally statement, and you can see here that the catch block wrote to the console, file not found, could not find the file, test.txt. So the last keyword to look at then is the throw keyword. So in this particular block of code that we've created as an example, we've put some conditional logic in here to see if the file exists, and if it does exist, we're pretty certain that the block of code in the if block is not going to raise an exception. But if it doesn't exist, we've got the else condition, and we can use this throw keyword, which will create and raise an exception driven by us. And that exception is dealt with in exactly the same way. We've thrown the exception, which means it's then passed to the catch block. It's of type exception, and then we assign that exception object to our EX variable, and we can then use and access the properties and methods in that particular exception object. So just 4 keywords you need to know about in order to work with exceptions: try, catch, finally, and the throw keyword. Exception types and the base exception. So there are lots of different exception types. We could get a divide by 0 exception raised if we run this piece of code. So if I put a breakpoint here and we run this code, we will see that we break in the catch block because the exception has been raised in here, and that exception is of type divide by 0 exception. The type is important because we can use this in order to catch different types of exception and execute different blocks of catch code. So what we could do in this example, rather than just waiting and catching a generic exception, because we know the type divide by 0 exception, we could catch the divide by 0 exception. And when we run this piece of code, what we'll see is that we hit the breakpoint in our catch block, and we've caught the divide by 0 exception that was raised in our try block, and that exception type that was raised matches the exception type that's defined as a parameter to our catch block. So this gives us control over the types of exception we deal with and how and what code we run depending on the exception type. We can add multiple catch blocks with different exception types. So if this was not a divide by 0 exception raised here, then it wouldn't match here, but it would match this catch exception type here. Every exception is inherited from the base exception, so every exception type will match this catch block, where we use the base exception type as the parameter to this catch block. Note, if you were to place this exception, the generic or base exception, first, then every exception type would match here, and you would never get to the other catch blocks, and that's why we have the red squiggly line. And if we look at that error message, what we'll see is that we've got the compiler telling us that a previous catch clause already catches all the exceptions of this type of supertype exception. So the order is important. And usually you've always got the catch super or generic exception type as the last catch block in your code. One other useful trick, say that we were trying to anticipate multiple different types of exception we need to catch, but we want to run the same block of code in the catch statement or the catch block. We can use this syntax to catch different types of exception and run the same block of code for the catch statement. So in this example, we would hit the divide by 0. That would be matched by this. So if we put the breakpoint here, run that. We break in here. But equally, if we were to be running this set of statements first, and we had the file not found exception, then we'd still catch in the same catch block because we've got this conditional logic that matches two different types of exception. So this syntax can be useful where you want to run the same block of code for multiple different types or similar types of exception. One of the core concepts to understand when dealing with exceptions is where they are caught and how they're passed up the call stack. As one piece of code calls another piece of code, an exception raised at the lower levels will get passed back up the call stack to the higher levels until the first matching catch statement is found. So in this example, slightly daft, but we're looking to catch a divide by 0 error, but the actual error is going to be a file IO exception. So when we run this code, the exception is not caught. So we try to read the file doesn't exist, and we get an unhandled exception. That is, we haven't caught the exception because we were looking to catch the wrong type of exception. However, if we were to wrap the calling function in a try-catch block so that we try and call the read my file function and then we try to access the file in the lower level function, then the exception that's raised here is automatically passed back up the stack. So in this example, when we run this program, what we'll see is that the exception is not caught in the lower level function down here because we're trying to catch the wrong type of exception, but it is passed back up to the higher level function in the catch block from the calling function. A couple of things worth mentioning about this though. When this is executed, you'll notice that even though the exception is raised here at the try block of code, the finally block of code is executed, finish the file read operation, before the exception is passed back up to the calling function and the try catch block in the calling function. Typically we'll structure things so that the types of exceptions we catch are more specific the closer to the code where they're likely to be hit. So in this instance we would have the catch block here looking for the file not found exception, so that all the file access and file read functions here in the try block are caught close to where the code that's being executed is found. And then we'd have the more generic exception types caught at the higher levels in the stack, as we do in this example, where any exception that's passed back up to from the calling function is caught with a generic exception type catch block. Okay, just a quick few points on variable scope within try-catch blocks. So any variable that's declared outside of the try-catch finally blocks will be accessible within all of those blocks of code, which is fairly straightforward and logical. However, anything that's declared inside one of these blocks, the try, catch or finally block, is local and only visible within that block of code. So if I was to declare the name of the file in the try block here, then this variable file is only accessible within the try block. So if I try to access file in the catch block in this instance, what we'll see is that the name file does not exist in the current context. So we have to be careful where we declare these variables if we need those variables to be accessible within the try, the catch, or the finally blocks. Another really useful technique to understand is creating custom exceptions. So if we take our existing functionality that tries to read a file that doesn't exist, and at the moment we just catch the generic exception object and pass that into the catch block to deal with, but what we might want to do is go about creating our own exception type where we throw our own exception, which generates an instance of our own exception object. And you can do that quite simply by creating a new class which inherits from the base exception class. So here I've got class my test data file not found exception, which inherits from the base exception class. And then within that class I define the constructor, so my test data file not found exception, and it's expecting a string variable when we throw the exception, and that is then used in the constructor of the base exception class to create and format our error message. And what I'm kind of getting across here is that maybe this exception is designed to deal with some test data cleanup or some scenario where you need to reset after an exception of your particular type has been thrown. So it needs to be custom code. And once we've created that new exception class, we can utilize that in our try catch block with this sort of syntax. So what I'm trying here is I'm testing to see if the file exists. If it doesn't exist, then I use the throw keyword to create a new exception of exception type my test data file not found exception. And I pass in that string variable, which is the file name. And when that's thrown, what I need to then do is catch that exception of that specialist type. So this would be catch my test data file not found exception. And that catch block will then contain my custom exception type in the EX variable. And I can then use the console write line. So in this way I can use my exception, my custom exception, to run any generic cleanup code, and in this particular catch block I can use a bit more custom code, but I've got a common type of exception that I can reuse and throw when needed. So just to reiterate, it's far easier to create your own custom exception types than you'd think. You just need to create a new class, and that needs to inherit from the base exception class, and then in the constructor we just pass in the parameters, and then we put in our custom code for our custom exception type. So in this video then we've looked at the keywords you need to understand when dealing with exceptions. That's try, catch, finally and throw. We've looked at the different types of exceptions that you might encounter. We've explained how you can pass those exceptions up the stack from different methods that you're calling. And then we had a quick look at the scope of variables in the try catch block. And we finished off with a quick look at the custom exceptions to see how you can create your own custom exceptions and throw those exceptions. In the next video, we'll look at Selenium specific exceptions, how to deal with them, and some good practice for implementing exception handling in your Selenium projects.